Hi dear students, welcome back to computer science class. We have already started learning data models in DBMS, database management system, and have completed the first data model, hierarchical data model. You know what actually data model is? Data model defines how the logical structure of data is modeled, right? And in hierarchical data model, the way we arrange things is like a tree. It's a tree-like structure, upside down tree. It means root on the top of the tree, and it follows 1 to m. One to many relationship. And here we have two more data models to discuss. The first one is network data model, and the third one is relational data model. And today we can in this session we can let's start with network data model. In network data model, it's a flexible way of representing objects and their relationships. We know data stored in the form of objects, okay? So it's a flexible way of representing objects, and of course these objects must be connected, and that's what relationships is, okay? Relationship is. Then it's a collection of records. It's a collection of records which are connected to each other, right? It's a collection of records which are connected through links. Of course there will be records, and these records are connected through links, okay? Yes, and of course unlike hierarchical data structure, and we know hierarchical data structure follows tree or tree-like structure. Here it follows graph, or it uses graph. Okay, other than tree, here in other than tree in the case of hierarchical data model, here in network data model it follows what? Graph structure. Okay, then we know in hierarchical data model the relation is 1 to m, 1 to many, but here it is m to m, many to many relationship. Okay. So there is not such a concept of parent-child. Okay, of course there is a parent-child, but in hierarchical there is only one parent and many children, right? But here we'll have multiple parents. Yeah, there will be multiple parents for a child. Okay, so that must be what in your mind. Okay, yes. So here is a diagram. We have the same records that we have seen in the case of hierarchical data model. Okay, here we have a student as a parent, and library, exam and fee. Okay, it's the same records. Yeah, in student we have roll number, name and address as fields, and in library we have roll number, ticket number and book issued. Then in exam, roll number, first term, second term and annual. Then fee, roll number, tuition fee, other fees and total fee as fields. Okay, then you can see these arrows. These are bidirectional, right? These are bidirectional, and of course that means data flow from student to librarian, from library to student. Okay, when we consider what exam, you can say exam is a what is a record. Okay, is a child record which has parents, exam is a child record which has multiple parents. And which are the parents of exam? Student is a parent of exam. Then you can see this one, right? So library is a parent of exam, and of course yes, you can see what fee is also a parent of exam. Okay, see the arrow, it's bidirectional, meaning data flow to and fro, right? Okay, so here in the case of network data model, it is m to n. Okay, what? Many to many relationship, okay, hope you get it. Yes, then let's see some of the advantages and drawbacks or limitations. And advantages, the first one, it handles more relationships. We know it follows m to m, many to many relationship, other than 1 to m in the case of hierarchical. Okay, so it handles multiple relationships, as we have m to m relation. Okay, many to many relationship. Then data access is more easy and flexible. Okay, data access in the case of network data model is more easy and flexible. Then it includes DDL and DML languages, like data definition language and data manipulation language. Okay, then it promotes data integrity. Of course every data model provides data integrity. It must provide data integrity. Okay, we are manipulating data, so we do give maximum importance or vital. Of course we know data is vital. Okay, so it provides or promotes data integrity. So these are the advantages. And when we look at the limitations, the first point is it is complicated in structure. We know it is somewhat complicated in structure because there is no such a single parent and many children. There will be multiple parents and multiple children, right? So it is complicated in structure. So number of links, as we have, as you can see, many links, and it makes the model less efficient. Okay, it means the structure itself is complicated, as we have multiple links, okay, as we have multiple links to connect the records, so it is less efficient. Then structural change may change in applications, of course, in the case of hierarchical, network and relational. Of course, when we do change the structure or the pattern or in the arrangement, the application should also be changed. There is no doubt in it, okay, yes. Then third one, high level language interface is required to interact with the DB. It means when we follow this network data model, we have to design high level language interface, okay, or high level language interface is needed to interact with what, the DB, okay, yes. And finally, we have number of links here. So as we have as I've told you in the last hierarchical data model, when we have links or pointers, it takes what, more memory, okay, extra memory is required. And here we have two examples, UNIVAC's DMS 1100 and DBMS 10 to 20 DEC, okay. These are two examples of what, network data model. Yes, so this is what network data model is. Main points, of course, it's a collection of what, records which are connected by links, and it's a flexible way of representing what, objects and their relationships, or records and their relationships, and it uses graph for representing, okay, data. And of course we'll have links, okay. Then it follows many to many relationship. Of course there is not a single parent, there will be parents and children, okay. You have seen it, yeah. Advantages, handle more relationships, data access is somewhat very easy and flexible, includes DDL and DML, promotes data integrity and complicate limitations, complicate in structure, it makes it less efficient, structural change needs a change in the application, high level, okay, interface is required for interacting with the DB and extra memory, and UNIVAC's DMS 1100 and DBMS 10 to 20 DEC are examples for network data model, okay. Now it's about relational data model. As we know, we have been following relational data model in our +1, in our +2, we're going to use it, right? Okay, so relational data model is the most commonly used, the most widely accepted data model, because it is scientific as well as what, efficient, right? Scientific as well as stable, because there is no link. As we have seen in the case of hierarchical network, we have links, right? Links are used to connect records. But here in the case of relational data model, there are no links. What is the problem with having links to connect records? Because if there is any problem happening to the links, it will definitely what, affects the consistency and validity of data. So it may be going what, inconsistent, as well as it reduces the integrity of data. So in relational data model, there is no such problem, because here we don't have the concept of links, okay. So links may result in inconsistency and data what, reducing integrity of data. And we know in relational data model, we organize data in the form of a two-dimensional table, and it's called relation, right? You know what is a table or a relation? A relation can be also termed as table, right? So but there is a specific difference between a table and a relation. All what, relations are tables, but not all tables are relations. We know that, right? Okay, all relations are tables, because relation means a table, but all tables are not relations, okay. You know the meaning, you got the concept, right? Okay, so here in data is organized using two-dimensional tables. It consists of rows and columns, and relations, we know, in a database, when we develop student software, okay, there will be multiple tables, right, or multiple relations, and these relations should be connected to each other, right? And it is the relational data model is developed by EF code, Edgar F code, okay. Then the content permanently saved for future use, we know that, okay. Then it's simple and storage efficient. Relational data model is simple in understanding, simple in use, okay, and it is what, storage efficient. And of course we know it's a collection of tables, and these tables are connected, and each table must have a unique name. Each table must have a unique name, okay, yes. Then let's look at some of the characteristics of relational data model. The first one, data organized in relation or using relations, okay. Data organized in relational data model using relational. That's why it's such a name, relational, tabular, okay. Table consists of rows and columns. Second, relation represented as tables, we know that, okay. Relation means a table. Relations are represented using tables. Then columns are also called attributes, okay. You know the specialty of column. Column contain what, individual values or separate values, or having what, unique data typed values, right? Yes, roll number consists of integer values, name consists of what varying character value. Okay, yes. So columns are also called attributes, and row represent a single entity. You know, data is stored row wise. That's what a record is actually. Okay, data stored row wise, so it is considered as represented as a single entity. Okay, then meaning details of a student or details of an entity stored in a single row. Okay, then values are scalar. That means only one and only one value, means only one value should be there in a column or in a row. Row instance, there will be multiple values in a row, but in a column there must be only one value. Okay, there won't be, it doesn't permit multiple values. It permits only one value. That is what scalar is. For example, roll number, we can have only one value for roll number in a row, right? We can have only one name in a row. That's what scalar is. Then all operations performed on entire relation results in another entire relation, meaning all operations are performed on entire relation. So the result will also be affected, or what will be resulted in another relation, meaning it affects the entire relation. Okay, it results in entire relation or changes. Yeah. So these are the characteristics. And now let's look at advantages. Advantages of DBMS. That these advantages make what relational data model the most commonly used one. Okay. Yes. We have already used it, so you know the structure, you know the pattern, you know how we are creating a database. After that, how we are creating a table on the database or tables on the database, how we are connecting these tables with the help of keys, right? Okay. So yeah, advantages. Structural independence. Structural independence means we know we follow modularity. We don't create a single table for storing the entire data. We are creating multiple tables. Okay, we know there are two types of files: flat file and relational file. Right? Flat file means it's a single table having all kinds of data. Actually, flat files are used for small applications. Okay, but relational means having data stored in multiple tables, and these tables are connected. Okay. Yes. So structural independence, that means we will have multiple tables. So that is what independence is. But anyway, if you want to fetch information from more than one table, you'll have to connect these tables, right? So that is what actually structural independence is. So independent tables, okay? But at the time of implementing, you'll have to connect it, okay? Yes. But anyway, physically these are independent. Yeah. Then structural change, no change in access or data access or other applications, because as we have seen in the case of hierarchical network, when we change the structure or the pattern, what we want to do is it will definitely influence all the applications, which which uses this hierarchical network. But here in the case of relational data model, when we change the structure, there will not be any problem in accessing data or in other applications. Okay, it won't affect the applications or data access. Yeah. Then tables of course we know not at least here in a relational model we are using this tabular structure for storing many types of data. We have used Excel, okay, or you might have seen in your report card. Everything means most of the things, especially numeric value, are represented using tables, right? Okay, yes. So it's very easy and simple. Then tabular view design, okay, means tabular view design wise use, implementation and management makes easy. Okay, that is tabular view design makes the using and implementing and managing makes easy. Okay, yes. Then built-in query support, SQL, which uses RDBMS. Okay, RDBMS stands for Relational Database Management System, a database management system that follows relational data model. Okay, yes, there is a built-in query support system because we have stored procedures, right? Okay, in SQL, meaning already developed or saved queries can be used. That is what built-in is. Yes. So built-in query support system is here in SQL, which is supported by RDBMS. Yes. Then data organization is easy, flexible and faster. Okay, you know, tabular structure makes data representation easy, flexible and faster. Yes. Then isolate end user from physical level details. Okay, because end user as of now we end users, right? Okay, yes. So end users don't have to look at the physical aspect or the internal things about how data is stored, how it is fetched off. Okay, all this kind of stuff. So it isolates end user from physical level activities. User has to look at only how to use it. Okay, just to use. Yeah. Then math operations make easy using RDBMS because we have performed a number of operations. Okay, aggregate operations or group operations, right? Sum, average. Okay, all those kind of count of. Okay, yes. So these are the advantages, and these advantages make relational data model, the widely accepted one. Okay. Then we have two limitations. Okay. It incur hardware and software overheads because there may be problem what interfering the hardware or software. Okay, but we do not focus mainly on this. Okay, it's just a limitation. Okay, then size of database will be very high, very large. Okay, as we want store data here, because anyway we have to use a model, right? So you don't have to look at these two in detail. Okay, yes, size of database will definitely become higher and higher as data storage is becoming high. Okay, you know that. Yeah, so these are the problems. Incur hardware and software overheads may be the big hardware or software and software. Okay, then size of database may be large. Okay, so these are the conceptual aspects of relational data model. Let's have a quick revision. Relational data model is the most commonly used, most widely accepted data model. Okay, then it's scientific and stable, which has no links. When we have links, okay, it definitely results in inconsistency and reduced integrity, right? Okay, then data organized in two-dimensional tables called relations, and there will be multiple relations or tables. Okay, these tables should be connected to each other and developed by or designed by EF code. Okay, then content permanently saved and stored. Okay, then simple and storage efficient collection of tables. Unique name must be there. Okay, then characteristics: data organized in relation, rows and columns. Relation represented tables, columns are also called attributes, row represents a single entity, value scalar, only one value permitted for a single column. Okay, or a row. Then all operations performed on entire relation results in entire relation. And advantages: structural independence, structural change will not affect. Okay, then tables easy and simple, tabular view, use, implement and manage makes easy. Yeah, then built-in query support. Using SQL by DBMS or in DBMS. Then data organization easy, flexible and faster. Then isolate end user from physical level activities or things. Okay, then math operations are also very easy. Okay, using this. Then limitations: incur hardware and software overheads, and size will be becoming high. Okay, so these are the data models. Hierarchical, we have started with hierarchical data model, then we have moved to network and relational data model. So you just go through all these topics. Okay, prepare notes, yes, based on this lecture as well as based on your textbook. Okay, you must have a thorough understanding of all this. Okay, we have a lot of points, we have looked at a lot of points. So these are very important in your exam point of view. Okay, so just go through all these topics in detail. So thank you for watching. Have a nice time. Take care.